Okay, so in each of these problems, you should think about what power correctly completes the exponential expression. So 5 to what power is 125? The answer is 3. This is a natural log, so I could actually rewrite it as log base e, so I can see the base. So e raised to what power will give me back e, which is itself. So the natural log of e is always equal to 1 because it's e to the first power gets back itself. This is a common log, so the base here is a 10. So 10 raised to what power will give me 1,000. So the answer is 3. 10 cubed is 1,000. This one is a little bit harder because we're going from 25, but we get 5 as an answer, and it's not a reciprocal. It's not like we're getting 1 over 25. This is actually a square root. So remember, fractional exponents from last unit take the square root of the number. So the answer has to be 1/2 because 25 to the 1/2 power is the same thing as the square root of 25 to the first power, and that does equal 5. So the answer is positive 1/2. This problem is actually identical to part D. So 36 to what power gets me 6? So that's another square root. So 36 to the 1/2 power is 6. If I set up F, let's see, 6 is the base. What power gets me the reciprocal 1/6? So that would have to be -1 because that would give me the reciprocal. So these say that I'm not allowed to use a calculator. So there must be a way to do the problem without a calculator. So on A and C, we're going to use the one-to-one property for exponents. And on B and D, we're solving log expressions. So let's do A and C. Maybe you know in your head that 3 cubed is 27, but 27 is in the power of 3 family. So if you weren't sure that 3 cubed was 27, and you just know the answer is 1, you could rewrite it with the same base on both sides. So 3 to the x plus 2 equals 3 cubed. So now I can set x plus 2 equal to 3 because of the one-to-one property. So x plus 2 equals 3, so I can subtract 2 to the other side and show that x must be 1 because 3 cubed gives me 27. This one's a little bit harder because it has an exponent on both sides. So I'm going to leave 2 alone, but I'm going to rewrite this 8 as 2 cubed. This x is still sitting here because this says 8 to the x, so this is 8 to the x. And now I'm going to leave this side alone. When I distribute an exponent, I multiply my exponents, so I actually have 3 times x, which is 3x. Now that I have the same base on both sides, I can set my exponents equal to each other. So x plus 1 is equal to 3x. Now I have to use algebra to solve for x. So I'm going to subtract x. So I have 1 equals 2x. So I'm going to divide by 2. So I now have x equals 1/2 is the answer. Same strategy using that one-to-one property. All right, on B and D, you are in log form and you're going to switch into exponential form. So the base of the log is 4. So the base of my exponent is 4. 4 squared equals x plus 1. 4 squared equals x plus 1. So if 16 is equal to x plus 1, I must subtract 1 on both sides. So 16 minus 1 is 15. I'm going to use the same strategy in part D, but before I change form, I need to divide both sides of the equation by 2. So log base 8 of x equals 2. So now I'm going to change into exponential form. The base of my log is 8, so the base of my exponent is 8. And then I have 8 squared, and then that is equal to x. So 8 squared is 64, so my answer must be 64. Okay, so properties of logs. When you've got the same log base, so this is both a base 10 log, and you're adding them together, you're allowed to take the two pieces inside the log and multiply them together. So 4x times 2 would give me now 8x inside the log. Here I have the same base, a base 5, and I'm subtracting the logs, so I can write them as x over y inside the log as one log. The bonus. So if you wanted to try the bonus question, if you notice, you've got a log base 4 graph and a log base 4 graph, and with a plus sign. So I'm allowed to take the x plus 3 times x plus 2 and multiply that together. And on the other side, I can kind of do the same thing, x plus 5 times x plus 1 and multiply that together. So the next step is to actually multiply these two binomials together. You can use FOIL or the box method. So you might have to go back and review that if you wanted to do this bonus. This is x squared plus 5x plus 6. And this is x squared plus 6x plus 5. So now that I have a log base 4 equal to another log base 4, I can set the inside part equal to the inside part because of the one-to-one property. X squared plus 5x plus 6 must equal x squared plus 6x plus 5. I didn't go dividing by log. I just know from the one-to-one property this inside must match this inside. The nice thing that happens, the first step would be subtracting x squared. Both of the x squareds cancel each other out. So you get the equation 5x plus 6 equals 6x plus 5. So I would subtract 5x to move the x's to one side. So that gives me 6 equals x plus 5. And then I'm going to subtract 5. So my final answer would be that x has to equal 1. If I plug 1 back in on my calculator, I could check that that works. This one, I said, don't bother graphing it because I didn't give you an axis, but can you find the equation of the inverse function? So if that's my original function, I'm allowed to switch x and y, and then I need to solve for y equals. So add 4 to the other side, divide by 2, and you could leave your answer like this, x plus 4 divided by 2, just like that. Or if you had to graph it, you might need to know that the slope is 1/2 and the y-intercept is at 2, 1/2 x plus 2. Okay, composition of functions. That's when you do f of g of x and you plug this in right there and you see if everything cancels out and you just get x. So 5 times 1/5 x plus 1 does not give us x because when I distribute the 5, I get an x and I get a plus 5. And that is not equal to x, so they are not inverses. Now, if this was equal to x, then I would have to check that the other composition also works. But because this one failed, I don't have to do a second check. So this is the graph of an exponential function, and this has been shifted right. So first I'm going to graph the points for 2 to the x. And when I graph 2 to the x, I just worry about these 3 points. 2 to the negative first power is 1/2. Anything to the 0 power is 1, and 2 to the first is 2. So I'm just graphing the parent function first. So 1/2, 1, and 2. What does this do? This shifts everything right 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So here's my final answer. And don't forget it has a dotted asymptote at y equals 0. So it should not go down here. It parallels it right here. The function's domain is all real numbers, and the range is that y is above the x-axis. So writing the equation of the function's inverse, this is more of an advanced test question, so that's why I made it a bonus. So x equals 2 to the y minus 4. Your first step is to switch x and y in the original equation. I'm stuck in exponent land. So I'm going to rewrite this in log form. So the base would be 2. The x is going to go inside the log, and that frees up the exponent, y minus 4, outside the log. So my last step to solve for y would be just add 4 to the other side. So log base 2 of x with a plus 4 would be that bonus answer. All right, so this time they're asking you to graph a log function. So some of you may not be as comfortable graphing the log base 3, but everybody should know how to graph the exponential function 3 to the x. Same way we graph 2 to the x with this table. But instead of 1/2 and 2, we're going to have 1/3 and 3. So 1/3, 1, and 3 is 3 to the x. And remember, log base 3 is the inverse function. Then I'm going to have to do this plus 2. But let's just do the inverse function. If this was 1, 3, my inverse would be at 3, 1. If this is at 0, 1, my inverse is at 1, 0. And then negative 1, 1/3, 1/3, negative 1. So this graph is 3 to the x. This graph is log base 3 of x. And now I need to do that plus 2 part. So plus 2, excuse me here, plus 2 and plus 2. So these black dots are my final 3 dots. So it's the green function that's been shifted up too. Now this does have an asymptote right here at x equals 0 because the original function has an asymptote at y equals 0. The log function has an asymptote at x equals 0. So its domain, x has to be this black curve greater than 0, all real numbers for the range. All right, if you wanted to do the bonus, you would switch the x and the y in the original function up here. And now I need to switch form, but before I switch form, I should subtract this 2 to the other side. Okay, now I need to change form. So my base is going to be 3, my power is going to be x minus 2, and that's going to be equal to y. So y equals 3 to the x minus 2 would be the answer to that bonus question. Okay, number 8, these are calculator questions. If you're stuck in log form, you need to transform the equation into exponential form. So the base is 6, the exponent is 1/5, the power in the number inside the log comes out here. So I'm going to type this into my calculator and then divide by 2 to get the final answer. Oops. So 6 raised to the 1/5 power divided by 2 comes out to 0.72. It says round to the nearest hundredth. So 0.72. On B, I'm in exponential form. I'm going to switch to log form, but before I do that, I'm going to divide both sides by 4. Dividing by 4 is the same as multiplying by 1/4. So I actually have 1/8. And now I'm going to switch into log form. The base will be e. So this is the natural log of 1/8, if you prefer to write it that way, equals 2x. So I'm going to take the natural log of 1/8 on my calculator and then divide by 2. Natural log of 1/8 divided by 2 is negative 1.04. Okay, a couple application problems, and I'm going to give you all of these formulas, and Newton's law would be a bonus. So I've got a half-life problem. I need to calculate K before I do anything else. So if I start with 100 grams, I'm left with 50. I don't know K, but I know that my time was 4,900 years. So my first step is to divide by 100. So 0.5 equals e raised to the k times 4900 power. I change it into log form, which is the same as taking the natural log of a half, and that is equal to k times 4900. So I'm going to take the natural log of a half on my calculator and then divide by 4,900. And it's going to come out as a really small number. So you need to recognize when you're coming out with scientific notation, this e to the -4 tells me that I'm going to write my k value -0.00014 because it was 1.4, but they slid the decimal back 4 spaces. So that number is equal to that k value. So kind of part 2, now I need to go back to the question. I want to know how old this 35% carbon leaf is. So I'm going to rewrite the original problem as 35 and 100. So I start with 100, I end with 35. Now I know K, but I do not know the T value. So if I were you, I would pause the video and see if you can solve for T. So I'm going to divide by 35, divide by 100 on both sides. So 0.35 equals E to the KT. I'm going to change into log form, which is the same as taking the natural log. And then I'm going to take the natural log of 0.35 and divide by that K value. So the natural log of 0.35, and then I'm going to show you the rounded answer and the unrounded answer. So this would be rounded, 7498.73 years old. I'm going to show you the unrounded answer. So natural log of 0.35 divided by the whole decimal, 7421. 742141 years. So depending on what you round to, I would accept either of these answers because you're going to show me your K value. So I'll know what you did and how you rounded. All right, number 10 is an application problem about compound interest. He needs, in 10 years, he has a goal of reaching $200,000. He's investing in stocks that grow at an average annual interest rate of 7.5%. That would be pretty good if your money was 7.5%. Average annual interest rate is this formula right here. So we want to get to 200,000. We don't know how much we are investing, but we know that we're getting 7.5%. It's annual interest, so N is just 1. And then N is 1 again times 10 years. So this number right here is just a number that's being multiplied by X. So we can find that number and just divide it to the other side to get X by itself. So let me find that number first. 1 plus 0.075 divided by 1 raised to the 10th power. Is that number 2.06? I'm going to take my 200,000 and divide by that number, my answer. So it should be about $97,038.78. So if they invest this much in stocks now, in 10 years, they should have their $200,000. A savings bond is sold for $100. So that's our starting price. It'll mature in 10 years and reach a value of $250. What annual interest rate does it need to earn if it's compounded annually? So I need to get to $250 starting at 100. It's compounded annually. I don't know the interest rate, and 10 years. So you could do guess and check. You could plug it into your y equals menu. What I would do is I would divide by 100 on both sides of the equation. So 2.5 equals 1 plus r to the 10th. So the 10th power is the inverse of the 10th root. So if you just went and took the 10th root of both sides of the equation, you'd get the answer. The 10th root is the same as raising something to the 1/10th power. So 2.5 to the 1/10th power is 1.096. So 1.096 is equal to 1 plus the interest rate. So when I subtract 1 from both sides, I get 0.096. So 9.6% was the interest rate. I'm going to show you if I type this into the y equals menu, r over annual raised to the x power. Let's go to year 0. Wait, nope. 0 would be the interest rate. So I'm going to count by like, that'd be 0.1%. So I want to see how long it takes me to get to $250. Wait a second. Oh, I put an X right here. I know that it's 10 years. So I shouldn't have put the 2 X's in. Okay, go back. All right, now my money is climbing up. I'm trying to get to $250, and then I get the 9.6% interest rate, $250 in the bank. This is a bonus question, Newton's law again, which if you want to see it, she's brewing coffee. She pours the cup of coffee. It's 85 degrees initially, and it cools to 81 degrees, it looks like after 4 minutes. Oops, I put room temperature here, right? So 20 plus parentheses. I need the equation. Initial temperature minus room temperature. Initial temperature minus room temperature, E, to the K times 4 minutes. So I'm going to subtract 20 from both sides, and I'm also going to record 85 minus 20 is 65. So I've got 61 equals 65e to the k times 4. Did I do my math correctly? 81 minus 20 is 61, and then what I do, 85 minus 20 is 65. So I'm going to take it and divide by 65 on both sides. So I get 0.938 equals e to the k times 4. Taking the natural log of 0.938 and dividing that number by 4. So my k value is negative 0.016. I'm going to use that k value to find the temperature of the coffee at 1:09 p.m. So I start at 85 degrees. Oops, I have to do this again. I have to do 20 plus 85 minus 20e to the k value times 9 minutes, because it's 1 to 1:09. So I'm just going to type that into my calculator. 20 plus 85 minus 20 e to the negative 0.016 times 9. 76.3 degrees, and we're in Celsius. So it's still pretty hot. And then those of you that tried the multiple choice, this is a base 5 graph because I went over 5 to go up 1. So this was C. This is the base 2 graph because I went over 2 to go up 1. And so this is kind of this weird one. We haven't really practiced it, so I'm not going to go into details. Process of elimination, that has the base of the 1/3. Let's see. Up 1 unit would be B. Left 1 unit would be D. Base 5 power of B. Looks like this one. 5 to the B equals A. Domain for an exponential is all real numbers because it would look like this. Range for an exponential function, but it's being shifted up 4. So it would be y is greater than 4. Usually it's y is greater than 0. All right, so 4 raised to what power would give me the number 16, so that'd be 4 squared. And then this is a fractional exponent. So I'm taking the cube root of -8, so that would be -2, because -2 times -2 times -2 gives me -8, and then I'm squaring the answer, so it looks like I would get +4.